Good evening, everyone. Hello. Good evening, everyone. All of you audible? Fine. The last class explained what are the different data types and also what their sizes in Java. Java having the two types of data types, primitive and non-primitive data types. Here, primitive are integers, floating point, characters are called as primitive data types. Non-primitive data types are the uh, arrays and classes. Here, what are the primitive data types? Integers, floating point numbers, and characters. Come to the first one, integers. Integers are classified into four types here. Integers are classified into four types. The first one is byte, short, int, and long. Here, floating pointer, as usual, in C also same, float and double. But in C, in Java, the difference between C and Java here, in C language there is no byte data type, but here we have the byte data type. Here we have the byte data type. We are coming to what are the here one more data type, that is a boolean. Already I said that enumerations in C language we can create our own data types for boolean data type in C language, but in Java we have the data type that is the primitive data type boolean. Boolean means plus or just true or false. True means 1, false means 0. Okay, true means 1, false means 0. Okay, now coming to what are the sizes of the all the data types here. First, coming to integers. Integers are classified here four types. Okay, look here. Long, the width of the long is 64, integer is 32, short is 16, and byte is 8 in terms of bits, not in terms of bytes. Here 64, 32 all are in terms of bits, not in terms of bytes. Long means 8 bytes, integer means 4 bytes, short means 2 bytes, byte means only 8 bytes. Sorry, 8 bits, 1 byte. It's 16 2 bytes, 4 bytes, and 8 bytes. Byte means only 1 byte of data. The ranges here all are the signed values. Okay, not positive, not unsigned values. These all are the signed. Okay, unsigned long and also signed long both are available in Java also. Okay, now coming to first one is byte. Okay, here the smallest integer type is byte. Okay, byte having the 1 byte of data, you have to create your byte variables using the byte and data types b comma c. Here b and c are the byte variables. Next, coming to short. Short means the short is the keyword for to declare the short variables. That means the short is equivalent to integer in C language. So now integer having the 4 bytes of data type here. Integer having the 4 bytes, but in C language having the 2 bytes in our compilers. Okay, next one is long. Long is the 64 bytes. Okay, look here. This is a small program class light. Okay, public static void main string args into light speed, long days, long seconds, long distance. Here light speed, that's in the range of integer, and days, long days, how many days, that depends upon the data type. Here light speed is 1,86,000. 1,86,000 is in the range of signed integer. Because of 4 bytes means 2 4 32, that's in the range of 1,86,000 is in the range of integer, that's not a problem. Days here is equal to 1000. Specify the number of days here. So now day seconds is equal to now a very important point in Java. How can you differentiate this is integer, this is the long? Okay, how can you differentiate? That means the differentiation between the integer and long, the long values are represented with the help of L. The number after number you write the L, that is called as a long value. Okay, that is called as long value. I said that this is also very clear in the previous class. Float and double. Okay, float and double means the float values are represented is with the help of F. float f is equal to 10.2 f. Okay, all of it clearly very simple. Float values are represented. Suppose 10.4, that is the floating point number, at the same time double number. 10.4 is the float or double. In C language, there is no restriction. That is 10.4 is either float or double. But in Java, 10.4 is a float or double. Simply you can write the 10.4 means that is considered as a double number, not a float number. How can you say this is the float number means 10.4 f? Okay, 10.4 f. Float f is equal to 10.4 f. Now the compiler can understand this is a floating point value. If no f, that is called as a double. Suppose if you want to declare the float value to float variable, definitely you should write the f. Otherwise, you will get the error. Float f is equal to 10.4, you will write in Java, you will get the error. Because of 10.4 is not a floating point number. Alright, said that what is the narrowing, what is the widening? What is the narrowing? The left hand side data type is lesser than right hand side data type. That is called as narrowing. Narrowing is not accepted in C language. Okay, float f is equal to 10.4 means, okay, 10.4 is the double number. It occupies 8 bytes. Float occupies only 4 bytes. How can you fit the 8 bytes of data into 4 bytes? Narrowing is not accepted. The narrowing is not accepted. Suppose float f is equal to 10.4 here. 10.4 is not a floating point value. That is double value. Okay, that is double value. Double d is equal to 10.4. You will write it. That's not a problem. Double d is equal to 10.4 f also accepted. Okay, double D is equal to 10.4 F is also accepted. I will show all these things here. Minute. Here this is the Eclipse IDE. Float F is equal to 10.4 F. Just now I said that float F is equal to, this is the error statement. Once the statement is written, float F is equal to 10.4 means the 10.4 is shown by line, red line. That is error statement. That is identified at compilation. Okay, that is identified, such kind of errors are identified in Java at compilation because of Java is the very strong type checking language. Strong type checking. But in C language, you can write it float f is equal to 10.4. You should not get any error. Should not get any error because of the reason is that is weak type checking language. You will write it. Suppose float f is equal to write 10 also. But here you can write it 10. Definitely will get the error. Will get the error. Okay, that's fine. 10 float f is equal to 10. But you have to differentiate. You have to differentiate float values and double values. How can you differentiate? This is a float value means you have to write it to 10.4 f. That's the double the 10.4 f. Once you can write the f there after 10.4, the compiler can identify this is a floating point value. That's not a double value. Suppose here I will write it double. What I am saying here, what I am doing here, everything you have, everyone you have to capture. Okay, double f is equal to 10.4 f. Any error here? No error. What is the reason? The reason is only the concept double is the higher data type. 10.4 f is the right hand side 10.4 is the floating point number. At right left hand side double is the, that is also floating real value but higher data type than floating point data type. Okay, higher data type than floating point data type. This is the reason. Okay, this is the reason. Why do you no error here? What's the reason here? That's the reason. Okay, the left hand side having the higher data type, the right hand side having the lesser data type means that is accepted. Okay, this is called as widening. Okay, this is called as widening. Widening is accepted but not narrowing accepted. Narrowing is not accepted. Narrowing means what's the narrowing? Suppose the same statement I will write it. Float f is equal to float f is equal to 10.4. Okay, this is the narrowing. This is called as narrowing. Because of this is the float value. Okay, this is the float value, but this is assigned double value. F is assigned with, okay, not F1. Float F1 is equal to 10.4, means 10.4 is the double value. This is the double value. Okay, this is the float value. Float is not, double is not assigned to float. Double is not assigned to float means what's the reason? Float having the 4 bytes of data, double having the 8 bytes of data. Left hand side having the lesser data type, right hand side having the higher data type means that is called as narrowing. Narrowing is not accepted. Okay, this is not accepted. Narrowing is not accepted in Java. Widening is accepted. Widening is accepted in Java. Okay, that's not a problem. One more here, by using double data type, byte data type, byte B is equal to 10. Okay, that is in the range of byte value. What is the byte here? This is the signed byte. Okay, this is the signed byte. Byte having the only one byte of data. The signed byte means the range of values are minus 128 to plus 127. Our number 10 is in the range of minus 128 to plus 127. It's not a problem. Suppose I will give 128. You will get there. What is the range of byte here? Signed byte minus 128 to plus 127. But what is our value assigned here? Byte B is equal to 128 means that is not in the range of byte. That is not in the range of signed byte. Definitely you will get the error at compilation. The line has shown, red line has shown means in the IDs are very intelligent. Once you have to type any typing mistake, there is a compilation error shown by red line. At compilation, there is an error. You have to rectify. No need to compile. Okay, no need to compile. What's the concept here? Simple. The concept is here. Byte B is equal to 128 means 128 is not in the range of byte. How do you assign the value? 128 to byte variable. How do you assign the 128 to byte variable? This is the problem. Okay, this is called as a strong type checking. Okay, this is called as strong type checking. At compilation, it has shown error. Strong type checking. At compilation, the types are also checked. At compilation, the types are also checked. It is called as strong type checking. Called as strong type checking. Java provides strong type checking. At compilation, the error has identified. If any such kind in C language, there is no such kind of errors finding by the C compiler because of C compiler is the weak type checking compiler. So after syntax analysis, you have the semantic. What's the semantic here? Syntax as per syntax, byte B is equal to 128. Exactly the syntax is correct. Data type followed by variable is equal to value. What kind of value is also checked at in Java compiler? What kind of data type it is, and also what kind of value is assigned, and what is in the range of value or not. It is in the range of value. 128 is not in the range of value. That is also identified by the compiler at compilation. Because of the semantics plays vital role, very important role in Java. Semantic. But how can you say strong type checking means? Strong type checking means semantic analysis is a very strong here. But in C language, semantic analysis is not at all strong. Whatever that value you have to assign for, whatever that there you will write it float f is equal to small b also. In C language, character b is also assigned to character floating point variable. No error has occurred. Syntactically it is correct. Okay, fine. It is accepted by the C compiler. But in Java, syntax is okay, but the semantic is wrong. What's the semantic here? This is the byte data type. Okay, 128 is not in the range of byte. 128 is not in the range of byte. That is the reason here we are getting the compilation error, red line. Okay, compilation error. This is called as a strong type checking. Okay, this is called as strong type checking. At the same time, one more is also byte strong type checking. A byte B1 is equal to 20. Byte B1 is equal to 20. So now I will write it. Byte B2 is equal to B1 star B. Okay, B1 star B means automatically will get the error. That means the multiplication, the multiplied value of 128 into 20 is also exceeding the value of signed byte. 128 into 50 into 20 is equal to 2560. This is not in the range of signed byte. Maximum signed byte is the signed maximum positive is the plus 127. That is the intelligence of Java compiler. For multiplication of two byte variables, the value can be exceeding the maximum value of the maximum positive of the value. Okay, that is also checked at compilation. If any error, automatically that means the multiplication is not possible. You can multiply two byte variable means the product is not in the range of byte. Not in the range of byte that is assigned to either short or integer or long. You can multiply two byte variables means the outcome is not a byte. Outcome is not a byte. You have to assign that value to higher data type, higher integer data type. Higher means here the short. Short is the higher data type. So suppose we have to write it byte b is equal to 128 and also this is also 128. Not 128, we'll write it 255. 255 means that is automatically will get the error. Suppose this is also 128. I will write it byte b2 is suppose this is not a byte short b2 is equal to b star b, okay, b star b1. Okay, this is also erroneous statement because of b and b1 is not in the range of signed integers. It cannot be multiplied. Suppose here this is 127 and this one is 127. 127, 127. A short b2 is equal to b into b1. That is also not in the range of. Okay, that is not also not in the range of. That means 127 into 127, 127 is not also in the range of short b2. b2, that means automatically will get the error. Okay, b into b star, b into b1 is also not accepted. These two byte variables are, suppose if it is integer, go. Okay, how it is decided, anybody? How it is decided? Congo 3?
Sir, multiplication is possible only the data type of the given data type ఒక సైజ్ అనేది ఆ రేంజ్ లో ఉంటేనే మల్టిప్లికేషన్ పాసిబుల్ అవుతుంది సార్. ఇఫ్ నాట్ ఇట్ కాంట్ పాసిబుల్ సార్.
Means, look here, your answer is somewhat better, but not exact. Look here,
ఓకే సార్.
byte value is equal to 127 into 127 means, what is the maximum byte here? Maximum value for byte 127. Suppose the next one is also 127. 127 into 127 means that is in the range of 50,000. 50,000 something. That's also in the range of short. Okay, that is also in the range of short. Suppose if you have minus 128, minus 128 into minus 128, then what's the value of minus 128 into minus 128? 255 into, that means 256 into, that is 32,768 nearly. 127, that is 15,000. That means the product value is not in the maximum values of the byte data type product, the value is not in the short. The maximum, the remaining values are accepted. Suppose byte B is equal to 10, byte B1 is equal to 10, byte B2 is equal to 20. Short S is equal to B1 star B2 means that is accepted. Actually, the 10 into 20 is equal to 200. That is in the range of short. But sum of the values of byte multiple product, two byte variables product of sum of two values of the byte, the value can be exceeded means that is removed from the multiplication. That is removed from the multiplication. Whatever now here, look here, why the integer is accepted means whatever that byte value, whatever that byte value, two byte values are multiplied, that value should not be exceeding the integer maximum. Should not be exceeded at any point, at any product, any two values you have to take the maximum values of byte, you have to multiply these two. The multiplication, the product value should not be exceeding the integer value. This is the reason. I think all of you understood here what is the intelligence of Java compiler. What is the intelligence of Java compiler? The Java compiler is very intelligent. How all these things are identified at compilation? If they provided a special code to find out all these things. Okay, to find out all these things, they provided a special code. What is the multiplication value? What is the maximum value? And two maximum values or two maximum byte variables values are multiplied means that value is not in the range of short means that is identified the error. The statement is identified as an error. That is very strong type checking. The Java compiler is very, very intelligent. If you want to try to do the mistake that will show error at compilation, that is called as a strong type checking. Okay, that is called as strong type typing. Strong type typing means the types are two different types are assigned to variables means that is also strong. That is also type taking, but not only such kind of. Even the multiplication after multiplication, the value has to be exceeding means that is also identified. Okay, that is also identified by the Java compiler. Java compiler is very very intelligent because of this. For this is following the strong type checking. Strong type checking. The type checking is the concept in the semantic analysis, not in the syntax analysis. C and C++ languages don't follow any kind of type checking. These two languages, C and C++, are big type checking programming languages. Okay, big type checking programming languages. Next one, okay, suppose Boolean. Okay, Boolean B. Okay, Boolean B. Okay, you have to assign. Already have the B. Boolean B3. Boolean B3. Okay, the default value of Boolean is B3. Boolean value is false. Okay, the default. One more important point in Java. Without initializing the value, you cannot print that value. You will get the error. Look here. I cannot give any value to boolean value. Look here. Here I am typing system.out. Okay, what are the different types of methods are available? That is system.out. Here I am using the println. What the variable I want to print here? B3. Okay, system.out.println B3. Okay, now I'll run this program. Okay, here having the error 10.4. I will remove this. Once again I will run. Errors exist in the required projects. There is the error once again. Okay, look here. Exception thread made. Unsolved problem. Syntax token. Delete these tokens. Dollar errors. No red line at all. I think all of you understood before going to execution, run your program. No red lines in your program, then only your program will be executed. Red lines are there in your program means simply you can catch it. Your program have the compilation errors. Simply you can catch it. Your program have the compilation errors. Now no red line. Now we have the red line. System.out.println B3. Why did you get such kind of errors here? B3 is already declared. What's the problem? Because of B3 is not initialized. Okay, B3 is not initialized, but here I am trying to print the B3. Okay, here I am trying to print the B3. Such kind of errors are also identified by the Java compiler. If the variable is not initialized, you cannot print the value. You cannot print that variable. But you know what's the default value of B3? What's the default value? Once you declare the boolean variable, the default value is the false. The default value is the false. Suppose if it is a byte value, the default value is the 0. Any integer value, the default value is the 0. But you cannot print that value. We cannot print that value. That's a disadvantage in Java. I think that's advantage or disadvantage. We cannot print the value. But you know what's the value initialized for all the variables? All the variables here, the values are initialized in 0, except character variables. Okay, then coming to, now here I am writing B3 is equal to, okay, B3 is equal to false. Whenever I initialize it, B3 is equal, suppose, here I am writing semicolon, just to watch it. Okay, B3 is shown as error. The line is shown, B3 is shown as error. Whenever I initialize it here, the error count, no red line, no red line. Once the variable is initialized, you can print the value. You can print the variable value. It's not a problem. Without initialization, if you want to try to print the value variable value, there's error. Keep in mind, all of you, these all are very important. Here, everything I shown, what I am doing here, what I am telling here, everything I am showing here. Keep in mind, at the same time, this is recorded. Okay, no problem. You have to, okay, once again, you have to watch it, all these things. You will get it. Definitely, you will get it. Okay, next one is how many number of bytes for character data type in C language?
One sir in C.
In C language and C++ also only 1 byte of data, but in in Java 2 bytes for character data type. Already I said that in the C class also I said that C language character set is following with the ASCII. Java language character set is following with Unicode. Okay, with Unicode. You understand? What is the ASCII? ASCII is the 8 bits of data. The size of ASCII is only 1 byte. 1 byte means what's the maximum value for 1 byte? 1 byte means how many number of bits? 8 bits. Okay, what is the maximum? 255 is the maximum. 0 to 2 power n minus 1. N is equal to 8. Okay, 0 to 2 power 8 is equal to 256. 256 minus 1 is equal to 255. 0 to 255 is maximum. 0 to 255 means total how many number of characters are represented with the help of 8 bits? 256 characters are represented. That means the less character set. This C language and C++ language are following the very less character set. Only 256 characters are available. But in Java, have the more number of characters. The character set is very long, very lengthy character set. Suppose 255 is the maximum. Suppose I have 256 characters means definitely 1 byte is not enough. It definitely 1 byte is not enough. Definitely will go for another byte. Already I said that. Number of times I said that in the classroom also. All of you carefully listen. Suppose 4 bits, I have 4 bits. Maximum you can represent 16 numbers. The maximum number is the 50, 0 to 50. Suppose if you want to represent the 16, you need the extra bit. That's the fifth bit. Fifth bit is starting from 60, ending with 31. If you have the 5 bits, maximum 32 numbers are you can represent. It's 0 to 31, but you cannot represent the 32. If you want to represent the 32, you need the sixth bit. You need the sixth bit. Once you can catch this point, same concept. 255 is the maximum. If you have the 256 characters, 0 to 255, suppose 257th character also in the character set, one byte is not enough to represent. For 256 onwards, you need the ninth bit. You need the ninth bit mean ninth bit is in the second byte. Okay, ninth bit is in the second byte. Whenever ninth bit is there in your number means you need 2 bytes. Okay, you need 2 bytes. The maximum number of characters in the character set of Java. Okay, how many number of characters here? 65,536 number of characters are available in Java character set. How can you say, sir? 2 bytes means 16 bits. 2 power 16. 2 power 16 is equal to 65,536. This is the reason the Unicode character set having the 2 bytes of data means 2 bytes of data for each and every character. This is the reason. The character set of Java is a very lengthy character set. Very lengthy character set compared to C and C++. C and C++ character sets are following ASCII. ASCII is the 1 byte of data, but Java compiler Java character set follows Unicode. Unicode has the 2 bytes of data. Because of Unicode is a very lengthy character set. Unicode is the very lengthy character set. So suppose in a classroom 60 is the strength means the room capacity is okay fine. Whenever it is a 120, you will take it as a single class. The room capacity should be increased. The people cannot accommodate it. 120 members cannot be accommodated in the 60 classes. You need extra chairs, extra tables, and extra space, okay, to sit the 120 members. Okay, to sit the 120 members in a class. Okay, please just keep in mind all these examples. Why do you go for second byte? Means the length of the character set of Unicode is more number of characters in the Unicode character set. Language having the English language having the how many number of characters? 26 characters. Okay, for 26 characters, you need 1 byte means, suppose 27th characters means, you need 1 more byte. You need 1 more byte. Whenever the requirements are high, the data type size is also, the size of the data is also increased. Why do you go for byte to short? Short having the less number of values, then you will go for integer. Integer having the more number of values. Why do you go for long? You have already integer. Why do you go for long? Less number of values in the integer. Then that is the reason you will go for long values, very big values. This is the thinking. Unicode having the 2 bytes of data, Java follows the 2 bytes of data. This is not a concept. Everybody knows once you read the book, everybody can understand all these things. But your maturity levels are different. Now to keep your maturity levels very high. What is the reason? 2 bytes of data per character means. What's the reason? C language having the only 1 byte of data, but why do you 2 bytes for Java means? Okay, Unicode. Okay, Unicode. Why do you once you can use the Unicode, it will increase the 2 bytes. Unicode is not increasing the 2 bytes. Character set following in C language is the Unicode. Unicode having the more number of characters. Not at all 256. How many number of characters in the Unicode means? What's your answer? How many number of characters in the Unicode means? What's your answer? ఏం చెప్తారు ఆన్సర్? In ASCII, how many number of characters in the ASCII? 256. Because of 1 byte. Unicode having how many number of characters? 65,536 characters because of 2 bytes. Whenever the input data size has increased, the data type size is also increased. The data type size is also increased. Suppose I want to represent 1 lakh. Can I represent with the help of chart? I am unable to represent by using chart. But I can represent that 1 lakh with the help of integer because of more number of bytes per integer. In Java, more number of bytes for integer in Java. But I cannot represent with the help of short and byte. Anybody can represent 1 lakh, the number 1 lakh with short and byte? No, nobody can represent. You can try to write it. Look here, I will show. Byte B is byte S1 is equal to 1 lakh. Error. Next part S2 is equal to 1 lakh. This is also error. Next S3 is equal to 1 lakh. No error for int S3. Reason? What's the reason? Tell me anybody, what's the reason here? Byte and short are
Why
not
reading,
represented.
sir?
1 lakh is not represented by byte and short because of the sizes are different. Byte having a 1 byte is the maximum is for 255, you can represent with the help of byte. Short is maximum 65,535 only. But our number 1 lakh means that's not in the range of byte and short. What is the reason 1 lakh is represented with the help of C, with the help of integer? The reason is only having the more number of bytes. ఇంతకన్నా మీకు ఎవరు చెప్ప- What is the reason for byte having the if 1 lakh is assigned to integer variable means the size has the size of the integer is more than byte and short. At the same time, the same concept you can apply for Unicode characters also. Suppose char already have char x is equal to, okay, here I will write it 256. Okay, char x is equal to 256. 256 is in the range of 1 byte. What's the range of 1 byte of 1 byte of maximum 255? But here I can assign 256 means 256 is also one of the character. Okay, I will show here. System.out.println. Let's then I can print the X. Look, I will remove these two. Wait. What's the character? Question mark. 256 character is equal to what's the 256 character? Mark. Unicode 256 equivalent of character is the question mark. Suppose I will check it. What is the 257? I don't know what's the 257th ASCII Unicode value, Unicode character. Just to check it. Okay, that's also I think after 256, whatever that the character has shown by question mark only. That means that's not a printable character. That's not a printable character. Suppose as per ASCII, 97 is the small a. I will check it. What is the 97 here? ASCII 97 means, okay, what is ASCII 97? That is small a. Okay, I will check it here. What is the 97? Unicode 97. Unicode 97 అంటే ఏంటో చెక్ చేద్దాం. Hmm. Unicode 97 is also small a. Capital A, capital ASCII 65. I will check it here. That's the same or any difference. Run as capital A. The extension of ASCII is the Unicode. Yes, am I right? Am I right? All the ASCII same as it is. Suppose I will give the zero, null character. I will give null character here in the single quote. I will check it. What is the ASCII value of null character? Actually, in C language, the ASCII value of null character slash zero is the null character. What's the ASCII value of null character? I said that in the class.
Zero.
Zero, very good. Cannot be printed, but ASCII value is zero. Sure, ASCII is zero, no doubt. That Unicode also that's zero. Char x is equal to null character. Null character ASCII is zero. Okay, that means the character is not printed. If the character is not printed by default, null character ASCII is zero. Okay, null character ASCII is zero. That is printable or non-printable characters. The character set having the two types of characters. Printable characters and non-printable characters. Suppose in your keyboard, whatever key you can press, all the keys are printing the values. No, not printable. Suppose you can press the enter, any printing character there? No, not printed. Okay, understand? So these all are very important. Unicode, what is the reason of 2 bytes of Unicode means Unicode having a more number of characters. Suppose I will give 65,535 here. Then I will run this program. What is the 65,000 equivalent? I don't know what's the value, but just check it. That's also non-printable character. That's also non-printable character. Finally, the conclusion of this all means whenever the character set having a more number of characters means more than 256 characters means you need extra byte. Suppose if you have the 256, suppose that is the signed unsigned byte. Suppose your number is 256, you cannot represent 256. You cannot represent 256. In C language also, unsigned I is equal to 65,536 means it will show the zero. It will show the zero. Because of that is weak type checking language. How do you assign the 65,536 to unsigned variables? Maximum is 65,535. If you want to represent 65,535, you need the signed long. You need the signed long. More than 65,535, whatever that number you have to represent, you need the long data type, either signed long or unsigned long. Either signed long or unsigned long you need, but you cannot represent with the help of unsigned integer. You cannot represent with the help of unsigned integer. There, the concept is there. The concept is there also. Why do you go for one more higher data type? Already you have the integer. Why do you go for long? Same concept you can apply. Why do you go for long? Integer having the less number of values, long having the very higher values. What is the reason higher values for long? Increasing the size of the data type from 2 bytes to 4 bytes. Unicode ASCII having the character 1 byte means Unicode having the what is the reason of 2 byte? What is the reason of 2 bytes means increasing the more number of values. You need one more extra byte. You need one more extra byte. This is the concept. So one more. What is the name of this ID? Here I shared one ID. What's the name of that ID? All of you check in your mobile at left corner having the name. What's the name of ID? What's the name of the ID? Leelavati?
Sanjana.
Hello. Sanjana is not an ID. Sanjay is a that is a project. Come ముందు చూడండి. Eclipse workspace. Eclipse is the IDE. Eclipse is the what's the name of this IDE? Eclipse. Here you can type your program, you can compile your program, you can execute program. If you want to any external JRE files, if you want to insert to your project, you have to do all these things. Because of this is the IDE, Integrated Development Environment. Already worked with IDE. That is the C is a turbo compiler, and turbo compiler is also IDE. In our lab, once you can click on DOS box, that's also IDE. You have to compile your program with Alt F9 or Alt C. You have to run your program with Alt or Control F9. Okay, they're having the loader, they're having the linker, everything. They're having the window properties. Editor is different. Editor means just you have to type the program, but you cannot compile. There is no compiler in the editor. IDE having the compiler, linker, loader, all are available in a single platform. Is called as IDE. Is called as IDE. Integrated Development Environment. Integrated means together. Integrated means together. What is together here? Compiler, JVM, all are here in the single to develop. What you have to develop here? The projects you have to develop. Otherwise, you have to develop your programs. You need one